As we work further with functions, we're going to start to see that functions provide us a contained little space in which we can do some calculations, we can create some variables, we can create new values, and that all of it is sort of self contained in that space or the scope of the function. And this means that if we want something to survive from that function, once we get outside of it, that we're going to have to return a value from our functions. Another way to phrase this is that the return value is what the function evaluates to. This may be familiar in a mathematical sense, such as when you have a function f of x and you provide 5 for x, then you get some result. F of 5 evaluates to some particular number as a result. In Python, the way that we indicate this, what the result of a value should be, is by the return keyword. And then we give it some variable name or some value that we want to return as the result from our function. So here you can see I've defined a meters to kilometers function. It takes a parameter called num meters. It creates a variable called num kilometers, and it stores in it num meters divided by 1,000. Then it returns num kilometers. You can see here that the return is the last statement in the function. And in some advanced examples, we'll see cases where the return statement is not the last line in the function, but it will always be the last thing executed by the function. Because we've finished, we've got our result, and we return that result. So you've seen many functions before in our previous examples that print out values. But print is only for displaying something to the screen. It doesn't actually give us back that value that it displayed. So if I were to print num kilometers here at the end and not return it, I would not get any result from meters to kilometers to be able to do later math with or anything like that. It would be nicely displayed on the screen, and this can be helpful to ourselves or to our users to see what came out of our functions, or to see what was done in our functions rather. But if we want to make some value available to other portions of our code, like other functions or to other things being done in the same line of code, then we have to return it. So for instance, here we returned the number of kilometers. That means that when I call meters to kilometers with 3,000 down here, that the result of that will be the number 3, because we'll take 3,000 divided by 1,000. Then I'm able to take that 3 and do more with it. I can do 50 plus that 3, and I can print out the resulting 53 from that calculation. You can also think of it as if meters to kilometers 3,000 gets crossed out and replaced with the number 3 once the function executes. This is essentially what Python will do for us when our functions return values. It will do just like many of us would do when we're running through some mathematical calculation. It finds the meters to kilometers piece, it calls that function, does the math, and then it sort of crosses it out and replaces it with the number 3 so that it can continue on in doing the rest of the code that's there and needs executed. Here's a direct comparison of two functions with the same name that do some of the same math, but one returns the value and one prints the value. So this double it with n there, if I called it with 2, for instance, then it would calculate the value to be 2 times 2, 4, and it would return 4. that means that I would have the number 4 in hand or in that line of code to store in variables or to do additional math with. On the other hand, the double it down at the bottom still calculates the value 2 times n, so we would have the 4 there, and then it only prints it. So the 4 would get printed to the screen and then sort of lost to our program. It would cease to exist in a way that we could talk about it or do anything with it. Here's some further example on this. We could write a function, cups to gallons, that converts from cups to gallons. There are 16 cups in a gallon, and so our function should return its result so that we can use it elsewhere. So in this example, we say cups equals 20, and then we do some test code to try out this cups to gallons function, which I'll show an implementation of later. So our gallons equals cups to gallons, called with that variable cups, which is currently equal to 20. So this should convert 20 cups to some number of gallons, and we can print it out and see if we got the result that we wanted to. We also would be able to continue to do more math and do more things with it, and we'll actually see how that could be particularly useful here in a moment. This is just an example of some test code, so if you want to try this out, you can test it out yourself and see if you get the right result by checking it with a calculator or checking it in your head. Similarly, we could write a function, gallons to liters, and we'll leave this as an exercise in class or to do on your own. We'll see code for cups to gallons later, but you can try out gallons to liters, or we'll try it in class. It converts gallons into liters, and there are 0.264 gallons in a liter. So similarly, we could have some test code for it. Store some number like 20 as the number of gallons, and then we call gallons to liters with that number of gallons, and we store it as liters and print out that result, liters. So why are we talking about these two functions? Because since they return results, we can build on those results. And so if we were asked to convert from cups to liters, rather than having to look up what the conversion is between cups to liters and write a new function that does that math, we actually could take in the number of cups in our cups to liters. We could feed that number of cups into cups to gallons and store that as the number of gallons. Then we could call to gallons to liters with that number of gallons, save that, and return that as our result for cups to liters. And again, we'll look at how to implement this either as practice on your own or in class. But we don't have to do any math in cups to liters because we can get the results of calling those other functions. On the other hand, if we stepped all the way back to cups to gallons and we thought about it just printing instead of returning a value, well, if we had it print in the line where we wanted it to return before, similar to our double it function before, where in one version it returned and in the other version it printed, if we do not return a value from a function, then its result is undefined. And again, you may have mathematical examples of functions that have results which are undefined, and they're very hard to use in other calculations after that point. Once you hit an undefined result, everything after it is not well defined usually either. And so likewise here, if I stored as gallons the result of calling cups to gallons, if cups to gallons did not return a result, then what I'm going to get in Python is this special and sometimes annoying value called none. And so when I print, I will print out none. And if I tried to do math with the gallons variable, I would be adding, subtracting, multiplying, or dividing from none, which is undefined and in fact can cause errors and cause our program to crash. And then we also wouldn't be able to build into these later things that we want to create. So printing, again, is only for displaying. It doesn't give you a result that you can use elsewhere. Why doesn't it give you a result? Why couldn't you just reach back and get those variables that were used inside of the function? The reason for that is because functions have their own scope. A scope is sort of a containment space where variables exist, and once you get outside of that scope, those variables stop existing. And this can be annoying, but it's actually a good thing. It makes it much less likely that our functions will mess each other up by accidentally using the same variable names. It's okay if they do. The version of count in one function is different from the version of count in another function, and we typically want it to be. And this can be especially important if there are multiple people working together on a piece of code, on a file, on a package, on a whole program, because it's very likely that those people might use the same variable names in multiple different places. And rather than having to keep some sort of global list of what variable names are allowed, oh, I used X already, so you can't use X anywhere, we just check our scopes. If someone else is writing a couple of functions, your partner is writing a couple of functions, and you're writing a couple of functions, then both of those functions could use X or count inside of them, and that's all right, because the scope of a variable is some limited set of places in the program where that variable can be referenced. For instance, when we defined those doublet functions before, they had a parameter called n. That n started to exist at the start of the function when the parameters were defined, and it ceased to exist at the end of those functions when we stop indenting and we stop being in the body of the function there. And that is why the version that prints the data but does not return it is a little less useful to us, because we can no longer access that n or the value that it calculated by doubling n. So if you want a value of a variable to be available inside another function, you have to pass it in using a parameter. If you want to be able to use the result of your function after it finishes, then you should return that value and then use the return value from your function. So finally, we have here the elusive and mysterious cups to gallons function. And this is just one way to write it. It takes in the number of cups as a parameter. It stores the number of gallons, which is equal to the number of cups divided by 16. It then returns the number of gallons. So inside of this space is the function's scope. Num cups starts existing right here where the parameters are defined. Num gallons starts existing right here where it's defined. And then we return num gallons, and both of those variable names no longer exist. If I were to try to print num gallons down here below the function where it's not indented, then Python would tell me num gallons is not defined in this scope. I can, down below there, have a separate scope. This is the global scope. The function has its own local scope, and then outside of any function is the global scope. So I say cups equals 20, gallons equals cups to gallons with that variable cups, which is currently 20, and I print the number of gallons. And then down below, I redefine gallons to be equal to cups to gallons with 40 as the parameter. And that's okay. That's passed 20 in as num cups one time when we called, and it executes the function, and it finishes and cleans everything up. And then it puts 40 as num cups, and it does new calculations, returns the value, and cleans up all of those variable names again. You might ask what would happen if we changed num cups to be named just cups, and we changed num gallons to be named just gallons. This might look like it's causing a problem here, because there's cups there, there's gallons here, and then gallons gets defined down below, as does cups. But in fact, this doesn't cause any problem at all. What it essentially does is it creates new variables named cups and gallons that are specific to this scope of the function. And we're often familiar with having different scopes for titles and for names in everyday life. For example, if I have two companies, Company A and Company B, if I walk into the building of Company A and I say, I'd like to speak to the CEO, if they give me a meeting, then I'll be presumably speaking with the CEO of Company A. That's one scope where the title CEO means something local to that scope. And similarly, then if I walk into the door of Company B and say I'd like to speak to the CEO, then I'm probably going to get a meeting with the CEO of Company B. And so the title CEO exists in two separate scopes there. And the same is true here. The title cups exists in the function scope, and it exists in the global scope. And the title gallons exists in the function scope, and it exists in the global scope. And that's just fine. They're recognized as two separate scopes here. This version of cups and gallons that is local to the function stops existing once we're outside of the body of the function. Here's another example. I've defined this print value function, which takes a parameter n. But before I defined it, I defined in the global scope this variable n that's equal to 10. So again, it looks like n is the same between print value, where it's a parameter, and the global scope, where it's defined to be 10. But in fact, the global scope's n will be what I get when I use the variable name n outside of my function. So down here, I print n, that will print 10. Then I call print value with 5. Now it creates a new version of n that's 5, and it prints out that 5. But once I exit the function, that new version of n stops existing. We're no longer in the scope where that existed. And so I come down here and I print n again. Well, this is in the global scope, and so it's going to refer to the n that was set to be 10 in the global scope. So you'll notice the order of when I define that global n doesn't really matter when there's a local n that sort of overrides it or sort of is specific to the context that I'm in. Python will look as specific as it can for a variable name. So if that n is defined within the function, it's going to look at the version defined specific to that function. Here's one more example that will help me to circle back around to some of our previous ideas too. I have calc1 and calc2. They're two different functions. They each take variables, or they each take parameters a and b. Calc1 gives a result of it gives a variable called result, the value a minus 2 times b, and then it prints that variable called result. It does not return it. And likewise, calc2 creates a variable called result and stores in it a plus 2 times b. So different result variable in each of these, and it will have a different value in each of these. And when it prints out result here, it will be different than the one above. Even though these were given the same values for a and b, I will get -5 from the first one because of that subtraction, and I will get positive 7 from the second one because of that addition. Now, when I say I will get that, what I actually mean here is that I will have printed out that value. So it's important to remember that things like A, B, and result exist inside of the scope of Calc 1, or a different set of A, B, and result exist inside the scope of Calc 2, but all of those go away the moment that I exit Calc 1 or Calc 2. And so if I wanted any of those results to be available outside of the function Calc 1 or Calc 2, then I must return them. If all I need is to display the value, then that's just fine. I can print here. But because the scope is ending, if I want a value to exist outside, I must return it. And likewise, if I want to be able to define a value to exist inside, to be passed in from some other place, like the global scope, like the 1 and 3 are done here, then I must have parameters, and I must pass those values in as parameters to feed things into the scope. So parameters feed into a scope. The scope is allowed to define new variables and do calculations, and then a return will feed values out of the scope.